Hi all. Today we'll be discussing the LeetCode problem of the day, decode the slanted ciphertext. So an original text is encoded using slanted transportation cipher to form a encoded text. So in this question, you are given an encoded text and also you'll be given the number of rows. So your job is to decode and find the original text. So for any string, there is some process after which it will form a encoded text. So let's see how the string is getting encoded in the first place. So here, let's say our string is cipher and rows equal to 3. So we'll build a matrix of 3 rows, and this original string will start inserting it from the first block, and we'll insert it along the diagonal. So first you'll start C here, and then you'll keep inserting the rest of the string along the diagonal. So C, I, and then P. So once this diagonal is done, you'll move to the next diagonal, which is this, and insert the keep inserting the remaining string. So we'll have H, then E, then R. After this, the entire string is done. So this is the resultant matrix. So once we have the matrix, if we check all the rows one by one and from left to right. So first we have CH space space. After that, we'll check the second row. Then we'll check the third row. So if we append all of these characters in this order, we will get the encoded string. So here we can see the first row is CH space space, which is this. Then we have space IE space, which is this part. And finally, the last row, space space PR, with space space and PR. So this is how we encode a given string to an encoded string. So if we see the first example, you are given input, which is the encoded text, which is this CH 3 spaces, IE 3 space and PR. And you'll also be given the number of rows. So your output should be the original text. So in this case, the original text was cipher. So that's what you'll return. Now let's look at the second example. So in the second example, we have this as a ciphertext, and we are given rows equal to 4. So in the first row, we have I, V, E, O, and 2 space. So that is what is filled in the first row, I, V, E, O, and 2 space. Then in the second row, 2 space, double E, D, and space. So the second row, 2 space, double E, D, and space. Similarly, this is the third row, 2 space, L, E, space, T, and E. Finally, the last row, 3 space, OLC. This is how the matrix is formed based on the encoded string and the number of rows. So once we have the encoded string, to form the original string, we just need to move along the diagonals. So first we have I, then space, then L, O. So this diagonal is done. We'll move to the next diagonal. B, E, then space, then L. So this diagonal is also done. Next, the third diagonal, E, E, T, C. So this diagonal is also done. Then O, D, E. This diagonal is done as well. So after this, the next two diagonals are just empty spaces, so we don't need to cover it. So once we iterate it diagonal wise, this is what the original text, which is I love LeetCode, and that is what the output is. So let's look at the third example now. Here, the encoded string is coding and row equal to 1. So this is a single row and 6 columns. So in this, if you want to get the original string, first we have to iterate on the first diagonal, which is this. So we have C, then next diagonal O, D, I, N, G. So these are all the diagonals. So this spells out the word as it is, CODING. So in this case, the encoded string is same as the original string, which is coding. Now coming to the constraints, the encoded string length will be up to 10 ⁶, and it consists of lowercase letters and also spaces. Encoded string is a valid encoded of some original text and it does not have trailing spaces. So that means in your encoded string, you will not have any trailing spaces. And finally, the number of rows will be from 1 to 1000, and all the test cases are generated such that only one possible original text can be found. Now let's go the approach. So let's take the second example where this is our uh, encoded string. So to get the original string, first thing is we have rows equal to 4. So using this and using the length of the string, so if you do length of the string divided by 4, you'll get the number of columns. So in this case, length of the string is 24, and when you divide by 4, you'll get the column length, which is 6. So here we have 6 columns. So one thing we can say, rows equal to 4, and we also got the column length equal to 6. So once we get this, we can create a matrix of 4 rows and 6 columns and just insert this entire string, each row wise. And after doing it, just iterate on the diagonals. And as you keep iterating, just add this characters in your answer string and just return it. So by doing this, we'll get the output, but we will need to create an additional space of this size. So we'll try to solve it in a better approach without creating any additional space. So let's see how we can do it. So again, the original string, we should visualize it as if it is given as a matrix, and we need to see how we can iterate on the diagonals. So because if we just iterate on all the diagonals, we'll get the original string, which is I love LeetCode. So here we can see the first diagonal says I space LO. This is the first diagonal. And second diagonal VE space L. So this is the second diagonal, third, fourth, fifth, and sixth. So these are all the 6 diagonals. And in this 6 diagonals, we can see that the starting point of each diagonal is the elements in the first row. So what we can do is we can just iterate on the first row, elements in the first row. And whenever we are at any element, we just have to iterate the rest of the diagonal. So when you're at V, you just need to iterate in this way somehow and add the characters in your answer. After that, you should move to your next character and then iterate on the diagonals. So let's see how we can do this as well. So first thing is clear is we need to just iterate on the first row, which is on these characters. So let me build answer as well. Yeah. So first we are iterating on the first row, which is the first 6 characters, which is the same as the column length. So first you are starting at I. So when you are at I, the next character is this empty space. And here we have column length equal to 6. So from this I, you need to move 1, 2, 3, 4, 5, 6, and 7. So if you move the number of columns plus 1 positions to the right, then you will come to the next element in the diagonal. So what I mean to say here is, here we are at I. So from this I, if you move number of columns plus 1, you will move to the next diagonal. So number of columns is 6. So we need to move total 7 positions. So 1, 2, 3, 4, 5, 6, 7. So 7th position is a space. And this space exactly denotes the next position in this diagonal. After this, again, if you move 7 positions right, 1, 2, 3, 4, 5, 6, 7, you will end up at L, which is again another point in the diagonal. So you started at I. So in your answer, first put I, then move column plus 1 positions to the right. Then you have a space. Then again move 7 positions to the right. Then you'll have L. Then again move 7 positions to the right. So 1, 2, 3, 4, 5, 6, 7. You will end up at O. And this O is exactly equal to the last element in the first diagonal. So just by doing this, we have got the first diagonal. Now let's repeat this process for the second character V. Now for this V, you will first add V in your answer, then move 7 positions to the right. So from V, 7 positions to the right is this E. So from V, the next diagonal element is E. So you'll add E to your answer, then move 7 positions to the right, which is this. It's a space. Then move 7 positions to the right, which is L. After this, if you move 7 positions to the right again, you will go out of the string. So you stop there. So now this diagonal is also done. Next, you will start at E and again repeat the same process. So from E, 7 positions will give you an E. So first you will add E here, then move 7 positions, you will end up at E. So add this, then move 7 positions to the right, you will end up at T. Then next 7 positions, you will end up at C. And after this, you'll go out of bound. So stop there. Next, you will start at O, and from O, if you move 7 positions, you will end up at D. So add D. Then move 7 positions, you will end up at E. And then if you move 7 positions again, you will go out of bound. So you stop there. So this diagonal is also done. Next, you will start at here. We can see this is an empty. So when you start here, this is an empty space. Then if you move 7 characters to the right, you will end up at again empty. And again, if you move 7 characters to the right, you will again end up at an empty. So this diagonal is done as well. Finally, you will start at this diagonal. So here, if you move 7 positions to the right, you will have an empty. Then again 7 positions to the right, again it's an empty string. So at the end, you will have all empty strings. So after this iteration, you have found the answer. But the answer will always contain some extra spaces at the end. So when you get the answer, just remove the extra spaces and just return it. So this approach, I'll quickly do it for the first example as well. So it will be a bit more clear. So in the first example, let me write it. C H. I'm just writing the encoded string here. So CH space 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 IE space 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 and P and R. Here we have rows equal to 3. So rows equal to 3, columns equal to the string length by row. So string length is 12, 12 by 3 is 4. So since column is 4, we just have to iterate on these 4 characters. And for each character, we have to jump column plus 1 positions to get the diagonal values. So let's see. So first we start at C, then we move 5 positions to the right. So 1, 2, 3, 4, 5. You'll end up at I. Then 5 positions, 1, 2, 3, 4, 5. You will end up at P. Then next it'll go out of bound, so you stop there. Next you will start at H, then move 5 positions to the right. You're at E. Then 5 positions to the right. You're at R. After this, you start at space, then 5 positions to the right. You're at space, and then again this is out of bound. Finally, you're here. Then 5 positions to the right, it's again a space, and 5 positions to the right, it's out of bound. So this is your output string, and from it just remove the ending spaces. So this is what is your answer. And same thing for the third example as well. We can do it. Here it is straightforward. We have coding. We have rows equal to 1 and columns equal to size by row, which is 6. So that means you just have to iterate on the first six characters. And first you're at C, then you need to move columns plus 1, 7 positions to the right, so it is out of bound. So next you will start here, then you move to the right, it's out of bound, and so on. So as you keep repeating the process, you will here as well, you will form the output string. Now let's quickly code the approach. So based on the constraints, we can see that the string encoded text length can also be 0. So let's quickly handle the edge case. So let's say if the string length is equal to 0, then we can directly return an empty string. So now first let's find the column length. So column will be string length by rows. So once we get this, like we discussed, we need to iterate on the first row. That is, in first row we have 6 columns, so we just need to iterate on the first 6 elements in the encoded text. So int I equal to 0, I less than, we can say column and I plus plus. Now for each column, we'll start incrementing the pointer column plus 1 positions to the right to keep getting the value. So first let me take j equal to I, and while j is less than the size, I'll move j plus equal to column plus 1. So at each point, we'll just store this answer, which is encoded text dot caret j. So let me just create a string builder. String builder answer, go to new builder. So in our answer, we'll just append this value. So once we append it, we'll move column plus 1 positions so that this will simulate iterating on the diagonals. Now finally, we need to delete the spaces from the end of the string. So suppose we have our string builder like this, and at the end we have 3 spaces. So initially, we'll set a pointer which will be at the last position. So n will be equal to answer dot length is 1, and we'll run a loop as long as answer dot caret n is equal to a space. So as long as it's equal to a space, we'll reduce the n value. So n will keep decreasing, and at this point, the loop will break. So n will be here. So once we have the end value, we can just return answer dot substring n plus 1. So this will return the string until this point. Let's test now. Yeah. Okay, let me submit now. Yeah, and it works. Now let's do the time and space complexity analysis. Coming to time complexity, first we are iterating on the number of columns, and for each columns we are iterating on the number of rows. So for any diagonal, at max you will have you can have the rows number of elements in the diagonal. So overall the time complexity will be the size of this entire matrix, which is equal to the size of the encoded text. So we can say time complexity is order of n, where n is the size of the encoded text. And coming to space complexity, so we are building a string builder, and it will grow in size, and at the end it will store the size of the answer string. So space also we can say it is order of n. I also have the code in Python. If anyone wants to view it, I'll add this in the description as well. And let's catch up in the next video.